mowing people interrupt. All right, so we've already talked about the parent form for a quadratic. The parent form, well, the parent function is just x squared, and then sometimes we put a number in front. So I'm going to call it ax squared, okay? So let's just graph x squared again. I know you did it earlier on. What is the vertex of x squared? 0, 0. And I'm going to go over 1, up 1 on either side. And then I could stop there, but I'm going to do one more just because it's the parent function. If you were to put 2 in and square it, what would you get? 4. So this actually goes through the point 2, 4 and negative 2, 4 as well. There, hopefully, you can see the curvature of the parabola. Okay. Now, when we put an A in front, what happens is we then use that A and we go left and right 1, that's from the vertex, and up A, don't we? As long as A is positive. We go left and right. Did I spell right incorrectly? I did. We go left and right 1, and that's what we did in our opener today, and up A. All right. Now, what happens to A when it's reflected over the x-axis? Who can tell me? A becomes what kind of number? Good. So when we see y equals negative ax squared, okay, when it's a negative A, the vertex doesn't change. The vertex is still 0, 0. That's not going to change. But what we're going to see is we go left and right 1, and we don't go up A, but we go down A. Okay, and so I'm going to just draw a little picture over here so you see that. There, so we remember. A is positive, looks like that. A is negative, looks like that. Good. Okay, now, by the way, if the parabola is opening down, is the vertex a maximum or a minimum? If this, in this case, is the vertex a maximum or a minimum? Maximum, because isn't it the highest point of the graph? And when it's opening down, the vertex is a minimum because it's the lowest point of the graph. Okay, that's how that works. Okay, so that was kind of our recap from day 1. Yesterday, day 2, we saw these things that look like this. And in math, we are not creative. Us math folks are not creative. So when something's in vertex form, guess what you can tell? The vertex. Vertex form gives you the vertex. All right, here's how they look. We're still going to have an A in front. And then I'm going to have in the parentheses x minus h parentheses squared plus k. Okay, if you want to take a peek and look at page 3 again, remember when it was in the parentheses, moved it right left, and then afterwards moved it up down. So it actually moves the vertex. And x is a liar. We'll write this up here, okay? X is a liar. So, when something is in vertex form, right away we can tell the vertex by looking at what those two numbers are. this number right here and that number right there. The vertex is HK. Vertex is HK. Okay. What else do we know? Well, this doesn't start at 0, 0, but we can still use A because we are going to go from the vertex. We are going to move left and right from, I'm going to draw an arrow so I don't have to write it out, from HK, and we are going to go up or down A from that. Sorry about that. Up or down A. And there's one other thing that we know. I've talked about this thing called the axis of symmetry. Does anybody remember what that is? The line cuts the parabola in half, and it has to go through the vertex. So the axis is going to go through the x coordinate of the vertex. It's going to be x equals h. Alrighty. So, here's our example. Would you take a look at this? The first thing I want you to do is figure out, think really hard, what is the vertex? Remember, x is a liar. Raise your hand if you think you know. Yeah. So if x was a liar, you would make it, instead of negative 3, 5, 3, 5? Yeah, is that what you said? I just didn't hear you, sorry. So the vertex is 3, 5. Would you go ahead and put the vertex on the graph? Always you want to try to find the vertex first. Then I'm going to move left and right from HK and up and or down A. Move left or what right? I should have written move 1 left or right, right? Alright, so am I going to go up or down? Down, because A is negative. Alright, so here we go. From my vertex of 3, 5, I'm going to move to the right one and down 2. I'm going to go on the other side to the left one, down 2. And then I'm going to draw my parabola. This would be the point 4, 3 and 2, 3. And then would you put a dashed line going through the vertex? This is the axis of symmetry, and it is x equals 3. Okay, so that is called vertex form. So, standard form. Standard form really, it tells you one thing. It doesn't tell you the vertex, but we can find the vertex. Standard form are the ones that we did on the top of page 4. I'll put the top of page 4 up so you can see it. Top of page 4. So they look like this, and I had you highlight I told you the last number was the same as the y-intercept. So that's what I want us to write. We have ax squared plus bx plus c. Unfortunately, we don't know a whole lot, we only know two little things. The first one is that this number is going to give you the y-intercept when it's in standard form. So I know that 0C is the y-intercept. I also know the width. Remember, A gives us the width, 1 unit from the vertex. Okay. But actually, without some work, I don't know the axis of symmetry. It's not like the one above. So what I'm going to do is I'm going to teach you how you find the axis of symmetry with the numbers in the equation. So what I want to point out to you is, do you see this A, B, and C? They go in alphabetical order. Where is A located? A is what's in front of x squared, B is what's in front of x, and C is the last thing. If you want to find the axis, what we do is we take the opposite of B, so we take the opposite of this number, and we divide it by 2 times A. That might not make a whole lot of sense to you, but when I do an example in a second, you're going to get a number for that. Okay. Now, here's one good little thing. Do you remember up above how I said the axis had to go through the vertex? So once you find the axis, you already know one of the coordinates of the vertex. So the vertex we usually call HK, and H is going to be what we found for the axis, negative B over 2 times A. How are we going to find K? We are going to do F of negative B over 2 times A. Well, what in the world do I mean by that? That seems kind of crazy. F of negative B over 2A. Does anybody know what I mean by that? All that means is, remember F of X notation? All this means is you're going to just plug that in for X. You're going to plug that in for X. Okay. This probably doesn't make a lot of sense until you see it, so that's what we're going to do now. Can I flip over? So we're not going to do this. These two things are going to be plenty for us to do today. We're not going to do transforming between the forms until tomorrow or the next day. But would you flip over, and I want you to take a look at our first example. Okay. And then I'm going to highlight the numbers in front of x squared and x. Okay, because what I just highlighted are my A, my B, and my C. Okay. All right, you might have to flip back and forth. Can somebody tell me what is the y-intercept? Very good. -7. Can somebody tell me, does this open up or down? Good. How do you know? Because what's negative? Good. Tell me A. Okay. Or the number in front of x squared. Down because A is negative. Okay. Now, so you don't have to flip back and forth, I'm going to write down the formula again. To find the axis of symmetry, we're going to do the opposite of B over 2 times A. Okay. So, help me out here. Tell me what B is. B is 12. So I'm going to take the opposite of 12, which is -12, divided by 2 times negative 2. And let's make sure we just, if you're one of those calculator people, don't just rush and punch things in your calculator, because we could probably do this in our head, okay? What's 2 times negative 2? Negative 4. What's negative 12 divided by negative 4? 3. So now I know the axis of symmetry is 3. What else does that tell me? The vertex starts with 3 something else. Okay? Okay. Now I said to find the something else, you do f of this. So I'm going to write f of 3, and I'm going to show you what it means. All that means is up here in this equation, we are going to replace x with 3. So we are going to do negative 2 times parentheses 3 squared plus 12 times 3 minus 7. Okay, so I'm going to do, again, go ahead and use a calculator if you want, but make sure you put parentheses in, okay? I'm going to do 3 squared first. What's 3 squared? 9. And so then negative 2 times 9 is negative 18 plus 36 minus 7. What is it? Thank you, 11. So the vertex is 3, 11. Okay, so it took a little bit of time, right, to find the things that I needed. When you're graphing, guys, you always want to start by graphing the vertex. I know you can find the y-intercept right away, but it's not necessarily, unless it's the same thing as the vertex, it's not where I want to start my parabola, okay? So would you graph 3, 11? Okay, can somebody tell me what else I can do? How can I get some more points? Can I go over 1? Down 2? I could. Very good. Why could I do that? Because A is negative 2, and it tells me how far away those points are when they're 1. Unit to the left and right. And now this is where the y-intercept comes into play. If I know the y-intercept, let's go ahead and put it on there. 0, negative 7. Okay, that's just going to help me when I make my parabola. It's kind of skinny, isn't it? Alright, so I have 3, 11. I went over 1, down 2, so that's 4, 9. I have 2, 9. I have 0, negative 7, and couldn't you also go over here and put that point on there too to get some symmetry? Yeah. Let's see. Here's the middle, that's 3 away. Now, really carefully, because it's kind of narrow, try to draw a U through those points. Oh man. Oh. And I got a little shaky there. And then the last thing I'm going to do is just a dashed line through the middle. That's the axis of symmetry.